assignments. We're good with everything so far. 661, 662, 663. There's no questions on the homework assignments. What we're looking at today is inequalities. Inequalities are going to be essentially the exact same as our solving exponentials. So the way we solve exponentials is going to be the exact same way we solve inequalities. So what we need to do is get the term with the variable and the exponent by itself, which we have. And then we're going to apply a log to both sides, and it would be log base what? Log base 3. And the reason we use log base 3 is because our log base 3 of 3 to the x will become is less than log base 3 of 20. Now that we've gotten the variable out of the exponent, we can get x by itself. Well, here, x is indeed by itself. That's it. Log base 3 of 20 is a number, but it's not going to be a nice number. It doesn't simplify, so we're just going to leave it as this here. Questions on this here? So that's it. That's all we have to do for this here. We're ready for the next one. E to the x is less than 2. So in this case, we would get e by itself, and e is indeed by itself. And what would we apply to both sides to get the x out of the exponent? Almost. ln. ln, the natural log of e, ln. And the reason we use ln is ln of e to the x becomes x is less than the natural log ln of 2. Natural log of 2 will only simplify nicely if what's inside is e, so we can just leave it as ln of 2. And that's it. And there are no restrictions. There's nothing we have to add to these exponential inequalities. It's just this here. Because the value of x that we have in the exponent can be positive, it can be negative, it can be rational, it can be irrational. We can have any real number that we want. Questions on this here? So, the next one here, we have 10 to the 2x minus 6 is greater than 3. What would we do first? So we'd apply log base 10. And luckily for us, log base 10 is our common log, so we can just write it as log, because the base is understood to be 10 if it's not written. And the reason we do this is because log of 10 to the 2x minus 6 is 2x minus 6 is greater than log of 3. Is x by itself? So what do we need to do? Add 6. And if we add 6, our negative 6 plus 6 would cancel, telling us 2x is greater than log of 3 plus 6. And last but not least, we would divide both sides by 2, telling us x is greater than Log of 3 plus 6 over 2. And log of 3 plus 6 all over 2 does not reduce nicely, does not reduce to a nice number, one of our integers. So that's our final answer. Questions on this here? Are we good with this here? All right. Now, when we start off with a logarithm, we do have to be careful because what's inside the log here, in our case, x, whatever this value is, the final number that we have inside the log cannot be negative or 0. So what we're saying in this case is that this value of x, the values of x that go inside this log, have to be greater than 0. Because whatever it is, that final number inside the log has to be greater than 0. Here, it just says x is greater than 0. So it doesn't really say a whole lot, but if we had something else, like x plus 9 inside the log, we'd have to start off by saying that x plus 9 is greater than 0, and then solving to see what value is going to be the last number that would make x be 0. So here, whatever our solution set is, has to be greater than 0. So in some cases, that will come into play. Sometimes it won't. But now that we have it, we'll come back to it if we need it. So what we have is log of x is less than or equal to 2. What do we need to do first? We need to put both sides to the base of, because we need to get the x out of the logarithm. Because our 10 to the log of x, the 10 in log, because the base is understood to be 10, would cancel out giving us x by itself. We're saying that x is less than or equal to 10 squared. Well, what is 10 squared? So we're saying that x is less than or equal to 100. Questions on this here? So this part of our statement here is saying that our solution set is all the values of x that are less than or equal to 100, yes? So any of those values would work, yes? How about negative 2? Because that would tell us that we have what? Log of negative 2 is less than or equal to 2, yes? Can we have that? Well, no, because we can't have a negative number inside the log, yes? So this is the case because this is, true, it is the solution set, but we said at the beginning what? X has to be greater than 0. Since those numbers were included, the numbers that we had to exclude were included, we have to come over here and put that 0 is less than x is less than or equal to 100. We have to add that back in. We have to remove those solutions like negative 2 from the solution set, because we can't have negatives or zeros. Whatever's going to make inside the radical, or not radical, inside of our logarithm be 0. So our actual final answer is 0 is less than x is less than or equal to 100. Questions on this here? Makes sense? We're ready for the next one. Next one we have is log of x plus 9 is less than 45. So if we looked at the restriction, what's inside the logarithm? It's actually just x. Because how it's written is just x. Now we are going to change it a little bit for this here so that we can see the other type, is that if the parentheses are written, x plus 9 is inside the log. Because it's understood, or the notation states that if there's no parentheses, it's just what's immediately after log. If there's any addition or subtraction, it's outside. I don't like it because it's based off an understanding that that's how it's supposed to be written, and that if there's no parentheses, we're supposed to understand that it's actually log parentheses x close parentheses plus 9. But for us here, I want you to go on and add that set of parentheses around the x plus 9. So what that's telling us, that what's inside the log is indeed x plus 9. So we need to see our restriction, what values x cannot be. So we're saying that x plus 9 has to be greater than 0. Well, minus 9 telling us that our values of x have to be greater than negative 9. Because for how this is set up with the parentheses, if x is negative 9, what's inside that log would be 0. Anything smaller than negative 9 would cause what's inside the log to be negative. And even if we had negative 8, well, negative 8 plus 9 is 1, so that still works. Questions on this here before we solve for the value of x? Okay. What do we put both sides to the base of? 10. Because our 10 and log would cancel, leaving us x plus 9 is less than 10 to the 45th. Is 10 to the 45th a nice number? No, it's a massive number. 46 digits long. So we're going to leave it as 10 to the 45th. Now we still need to get x by itself, so we would do what? Minus 9. Which is going to tell us x is less than 10 to the 45th minus 9. And 10 to the 45th minus 9 is a massively big number. But we'll leave it there for notation's sake, because that would be very arduous to write. Questions on how we got to this here? Now, the question is, do we need our restriction of x being greater than negative 9? Is negative 9 less than our 10 to the 45th minus 9? Yes. And since it is, it means we have to add that piece back in. So negative 9 is less than x is less than 10 to the 45th minus 9. If we'd have said no, because if it had been the other way that x was greater than 10 to the 45th minus 9, then we don't need it. It's not included. Questions on this here? Questions on anything we've done so far? We're ready for the next one. So we want to solve 2 times the natural log of x minus 1. Well, we're not going to put the minus 1 inside the log. We're going to treat it like it actually says it is. 2 times the natural log of x minus 1. So our restriction is what's inside our natural log has to be greater than 0. So here, it's just saying that x has to be greater than 0. Now that we have that, we can solve this inequality. What's the first thing we can do? We will, but we need to get the natural log by itself first. We can, I would do something else first. Yes. Because I would do the addition or subtraction first before we multiply or divide. Because we could divide by 2. So we would do the 2 ln of x divided by 2. We'd also have to divide the negative 1 by 2 and the 4. So it's a little bit easier if we add the 1 to both sides. So we're not dividing 3 things by 2. Because now we have 2 ln of x is greater than 5. If we divide both sides by 2, we're only dividing 2 things, which will tell us that ln of x is greater than 5/2. Questions on how we got to this point here? We good with this so far? Now what do we do? I said it a minute ago. What do we do next? E, we put both sides to the base of e. Because our e to the ln of x, e and ln will cancel, leaving us with x is greater than e to the 5/2. E. I'm just plugging this in the calculator to see what its value is. Well, e to the 5/2 is 12 point going on to this here. So really we're saying x is greater than 12 point that decimal, yes? Is this always going to be greater than 0? Because that was our other restriction, that x had to be greater than 0, yes? Because, well, we said x is greater than 0. Well, with x being greater than e to the 5/2, will it always be greater than 0? Yeah. E to the 5/2, 12 point, our decimal number is bigger than 0. So this is always true. We don't need it because x is always going to be bigger than it. We only need it if we start going towards 0. Does that make sense? And that's it. I did have more in the note sheets, but